to learn how to convert a number from binary from decimal system to hexadecimal system and vice versa. So let us see how we can perform these convergence. First we will convert a decimal number into hexadecimal number system, and you should note down one thing: the hexadecimal number system has a base of 16. So in this example, suppose we have to convert 423 base 10 into base 16. By mistake here it is written base 8, but you should read it as base 16. So we'll use the repeated division method, and this time we'll divide the number by 16. So divide this 423 by 16, we get 26 as quotient and 7 as remainder. Again we divide 26 this quotient by 16, we get 16 1 is 16 and remainder as 10. Since there is no symbol 10 or no digit 10 in hexadecimal, instead of 10 we have a, because 10 is represented by a in hexadecimal. So we'll write a here, and again we will divide this quotient by 16. 16 0 is 16 0 and remainder is 1. So we'll note down this remainder here. Since the quotient is now become 0, we'll stop this process here only, and we'll note down remainder from last to first. So we have the remainders as 1, a and 7. So the equivalent hexadecimal number of decimal 423 is 1 7 a 7. So this is how we can get hexadecimal from decimal number system. Then now convert in order to convert hexadecimal number to decimal, let us take this example. Suppose we have 1a7 as base 16 and we have to get its base 10. So this will be done in this way, as we did earlier in other cases. Here we will multiply each digit by 16, because the only difference is here the base is 16. So 1 into 16, a into 16, 7 into 16, and we'll add them. So this is a plus sign, this is also a plus sign. By mistake it is written as multiplication sign, but you will read it as plus sign here and here also. So 16 to the power 0 is, and then we'll put 16 to the power 0, then next power is 1 and next power is 2. So 16 to the power 2 is 256, 16 to the power 1 is 16, and 16 power 0 is 1. Now when we solve this, we get 256 plus 160 plus 7, and finally we get 423. So this is how we can convert number from decimal to hexadecimal and from hexadecimal to decimal in case of integer numbers or whole numbers. But if the number is fractional one, then this is how we can convert fractional decimal number into fractional hexadecimal number. Suppose this is the one example: 123.275 base 10 is to be converted into base 16. So 123 will be converted as we did in previous slide. So when you may use same process, and you will get 7b as the hexadecimal equivalent of this integer number, and the fractional part we will follow this method, right? So to convert 0.275 into hexadecimal, what we will do, we'll multiply 0.275 by 16, we get 4.4, right? And now we will leave out this integer part, which is 4, and we'll consider only this fractional part, which is 0.4. So 0.4 into 16 is 6.4. 16 4s are 64, 6.4. Again we will leave out this integer part and we'll consider only this fractional part, and again we'll multiply that fractional part by 16, and we get again 6.4. So the is 6 and fractional part is 4. So we can again multiply this 0.4 by 16, and we have to repeat this till we get 0 in the 0 in the fractional part. But as we can see, we are getting same digit in the fractional part again and again. So when this type of situation arises, we stop after 3 or 4 steps. So I am stopping here after 3 steps, and then we will note down the integer part, these digits, integer part digits from first to last, from top to bottom, not from bottom to top. So we will have 4, 6 and 6. So 0.466. This is how we can get fractional conversion of decimal into hexadecimal. You may also attempt the reverse of this, that is to convert 7b.4666 base 16 to base 10, following the same procedure or the methods that we followed with other number systems. So this is an assignment for you to check how to convert this number into this. This is an assignment for you only. Thank you very much. You may practice more problems based on this method.